In the video f equals v over lambda, frequency is proportional to 1 over wavelength. And that's why we get this graph here. In DP physics, we want to linearize graphs. We're going to change this curve into a straight line. If we know that frequency is proportional to 1 over wavelength, or some constant over wavelength, we're going to make the x value 1 over wavelength. So we just go to our table, make a new column. We're going to call this inverse wavelength. It will be 1 over lambda. The units will be centimeters to the minus 1. And the uncertainty we have to do, we'll ignore for now, we might do it afterwards. We'll see how the extension goes. I'm not sure yet. What formula can we get to 1 over wavelength? Well, here's the wavelength. So the formula will be 1 divided by this, and then fill down yes. Let's control these decimal places some. That's pretty good. Maybe one more. Yeah, one more is good. I'm going to copy these. I'm going to go to Logger Pro. I'm going to again make this a little narrower, this a little wider. We're going to go data, new manual column, inverse wavelength, shortening 1 over lambda. The units will be centimeters to the minus 1. And we're going to paste in our numbers. Now I want to keep this graph and make this graph a bit smaller. I'm going to go insert graph. It's guessing the graph that I want, and a guess is wrong. I tried, but it's wrong. I still want this to be frequency. Instead of wavelength, I was 1 over wavelength. And I'm going to auto scale from 0. Now I get this. I'm going to go linear fit. And remember, the 2 data points, at least for me, that were bad were these 2, which is the shortest wavelengths. And now for the inverse wavelengths, would be the largest number. So also, I want to ignore those numbers. Again, looking at our slope value, because now the slope value is going to be equal to the velocity. I'm going to drag this over sideways, not including those 2. And I'm going to get this value 354, which is similar to the 334 we got there. I'm going to say that the straight line gradient is better. There's more techniques happening here in terms of balancing the linear line. And this is the awesome extension. One small thing is having a proper superscript here. If you do this, that's okay, but we need to actually get better than that. The way to get better than that is using symbol salad. We're going to come here to superscript, and we're going to click on minus, and then I'm just going to paste it, and we're going to click on 1, and we're going to paste it. So now we have some beautiful superscripts. Okay, now we need to find the uncertainty in average wavelengths. Let's take this one, paste it here, say uncertainty in inverse wavelength. I'm going to put a delta there. Also, these need to be wrapped. So I'm going to come here, choose text wrap, and they should all be centered. That's better. Now, the uncertainty in average wavelength is going to be the uncertainty in the wavelength divided by the wavelength, and that kind of gives what's called a relative, like a percentage uncertainty, and we multiply that percent, or the relative amount, by the actual inverse wavelength. So we say equals 0.4, the uncertainty in wavelength, divided by the actual wavelength, multiplied by the inverse wavelength. Let me zoom in. Hopefully that zoom in works for you. So it is this uncertainty, 0.4, divided by this value, multiplied by this value, and the uncertainty is that. Autofill, yes. Again, we need to control our decimal places. And uncertainty should have one significant figure, sometimes two. So we're going to go, so these all have one. This one's a bit bigger. That's okay. So, and the uncertainty needs to match. Here I've got 4 decimal places. Here I've got 4 decimal places. So that reinforces my kind of rounding here that I just kind of chose to do because it'll look nice. But now there's a reason for it to looking nice. So now this is an example of more work gives you a better answer. Let's copy and paste this into good old Logger Pro. I could make this wider, or I could just scroll over. Then I'm going to go Data, New Manual Column. And this is going to be called Uncertainty in Inverse Wavelength. Then it's going to be Delta, Greek letter Delta. 1 over lambda. Where's the little lambda? There it is. And our units are going to again be centimeters to the minus 1. I'm going to paste in the values. I've already copied these because I knew what I was doing. I paste them in. Nothing happened because I need to tell Logger Pro to use a certain column, and I'm going to choose a certain inverse wavelength, and it puts these way. And notice that this one was bigger because it was here, but look, still if it was bigger, it doesn't help. These are bad dots. They are bad data. This is good data, and it's reinforced by close to the value that we want. So now I can copy and paste this into, here's my one here. I don't have all the questions yet in my answer version or what we're following on this video, and I'm going to paste in my linearized graph with error bars. Logger, Google Docs takes a while. Let's try 1, 2, and it appeared. Good. And then I would put a title of this guy, obviously. Graph 2, frequency or effect of inverse wavelength on frequency. And we're going to do the same things that we did here, but we're going to use the slope instead. The units here also at a higher level, I want you to see if these units make sense, because the slope should be the velocity. Right here we have hertz per centimeter to the minus 1. So figuring that out, remember a hertz is a number of times something happens per second. So a hertz is actually like a seconds to the minus 1. That's what a hertz is equal to. So justify for yourself the units are actually centimeters per second, and then convert these into meters per second. Very cool. Thank you for your effort.